The blackness of space hides secrets, but none as startling as the showdown between a Falcon 9 rocket and the rogue Comet 3 I-Atlas. This wasn't a predicted flyby. It was a heart-stopping dance with cosmic destiny triggering an unprecedented emergency. What many overlooked is that this interstellar interloper, traveling at immense velocity, shattered any pretense of routine. The aftermath? An entire command structure dedicated to protecting our orbital assets. Utterly frozen. You can see this everywhere, the quiet panic, the frantic scramble to understand what just happened, and the terrifying implications for future missions. The bullet from beyond. Deep in the vast expanse, traveling at a staggering 140,000 miles per hour, was Comet 3 I-Atlas. This isn't just any comet, it's an interstellar visitor, the third of its kind ever officially confirmed to streak through our solar system. Discovered by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, in Chile, its trajectory was immediately flagged as unusual. Its hyperbolic orbit and eccentricity over 6 meant it wasn't bound by our sun's gravity. It was merely passing through, a cosmic wanderer on a journey lasting potentially billions of years. You see, this object originated from another star system entirely, flung out into the cold void before finding its temporary, dramatic path near us. Its nucleus, estimated to be up to 3.5 miles wide, was shrouded in a coma of gas and dust, a bright cloud extending thousands of miles, making it much larger than its solid core suggests. As the Falcon 9 ascended, punching through Earth's atmosphere with controlled fury, ground teams meticulously tracked its path. At first, the alerts were minor, distant, a blip on the radar suggesting an anomaly. However, as 3 I-Atlas, an object millions of miles away, continued its silent, rapid approach towards its closest point to the Sun, an event set for late October 2025, its faint glow intensified. What many overlooked is the sheer unpredictability of such an object. While its main trajectory wasn't headed directly for Earth, its path intersected with various orbital planes, including one frequented by launch vehicles. Space Command's sophisticated tracking systems, a network of radars and telescopes spanning the globe, began to scream. A confluence of trajectories, calculated with terrifying precision, showed the Falcon 9's ascent path directly intersecting with the comet's expansive coma. Not the solid nucleus, but the vast, diffuse cloud of ice and dust surrounding it. The clock was ticking. The Falcon 9 was in its crucial ascent phase, gaining speed, preparing for stage separation. This is where the rocket is most vulnerable, its sensitive outer skin and delicate instruments exposed. To put it mildly, the margin for error was non-existent. The potential impact, even with microscopic particles from the comet's coma, could rip through the rocket's structure, causing a catastrophic failure. Imagine countless tiny grains of sand, each traveling at tens of thousands of miles per hour, effectively becoming deadly projectiles. The kinetic energy involved meant even a dust particle could cause significant damage, let alone the larger fragments within the comet's tail. Space Command operators, usually calm under pressure, felt a cold dread. They had minutes, maybe seconds, to react. This was not a scenario in their training manuals. The most shocking fact is that while we track hundreds of thousands of pieces of space junk, an interstellar comet with an unpredictable expanding dust cloud presented a threat of an entirely different scale. The decision had to be made: protect the multi-million-dollar asset and its payload, or risk an unprecedented public disaster. The order came through: an immediate emergency course correction. This was an almost impossible feat during a carefully choreographed launch sequence. The Falcon 9's onboard computers, typically programmed for a precise, predetermined trajectory, were instantly overridden. Using its grid fins, designed for atmospheric re-entry control, and by briefly firing some of its Merlin engines in an uncharacteristic burst, the rocket executed a sharp, jarring maneuver. It swerved, pulling away from the projected intersection point with the comet's leading edge. The G-forces on the rocket were immense, pushing its structural limits. On board, the satellite payload experienced stresses far beyond its design parameters. The maneuver, while successful in averting a direct catastrophic hit within the densest part of the coma, sent the Falcon 9 slightly off its planned trajectory. It had just narrowly avoided being shredded by an interstellar visitor, but the drama was far from over. But what truly happened to Space Command after this near disaster? The cascading crisis. The Falcon 9's evasive action while preventing a direct collision was merely the first domino to fall. You see, the sudden, unplanned deviation launched a cascade of unforeseen problems, creating an orbital ripple effect that stretched far beyond the single mission. The rocket, now slightly off its intended path, was still hurtling towards space, but its new trajectory meant a whole new set of calculations were needed for its second stage separation and satellite deployment. The flight controllers, breathing a collective sigh of relief, quickly realized their problems had only just begun. The thing nobody tells you is that in the intricate dance of space launches, every millisecond and every mile per hour counts. Even a small change can have massive implications for orbital mechanics. The shift in the Falcon 9's path meant that its fairing, the protective nose cone shielding the satellite, jettisoned at an unusual altitude and velocity. This resulted in the creation of unexpected debris. While SpaceX endeavors to recover fairings for reuse, this particular one shattered into hundreds of smaller, untracked pieces upon re-entry, or remained in a decaying, unpredictable orbit. This new cloud of debris, ranging from tiny shards to larger panels, instantly became a hazard. The United States Space Command's Joint Force Space Component Command, or JFSCC, which is responsible for tracking objects in orbit, was suddenly inundated with new data. Their systems, designed to track over 30,000 pieces of debris larger than a softball, struggled to process this sudden influx of smaller, uncatalogued fragments. It was like dropping a handful of marbles into a carefully organized collection. What many overlooked is that Space Command's primary mission isn't just tracking objects. It's also about preventing collisions, ensuring freedom of operation in space for military and commercial assets. This unexpected debris field directly threatened active satellites, including critical military reconnaissance platforms and commercial communications networks. Every piece of new debris needed to be characterized, its trajectory predicted, and potential collision warnings issued. The most shocking fact is that the number of close approach alerts, where two objects pass within a few hundred yards of each other, spiked by a staggering 150% in the 24 hours following the Falcon 9's maneuver. Operators worked frantically, issuing thousands of warnings to satellite owners globally. The danger of a Kessler syndrome event, where a chain reaction of collisions creates an impenetrable wall of debris, suddenly felt terrifyingly real. Furthermore, the Falcon 9's modified trajectory created a complex challenge for its second stage. Powered by a single Merlin vacuum engine, this stage typically delivers the payload to a precise orbit. The unexpected evasive action meant the second stage had to perform multiple reignition burns and a series of delicate maneuvers to compensate. This expended more fuel than planned, reducing the available margin for error and impacting the satellite's final orbital parameters. The operational teams had to rapidly reprogram the entire sequence, a process that usually takes weeks of simulations, now compressed into mere hours. The pressure was immense, the stakes astronomical. Every adjustment carried the risk of further destabilizing the mission, potentially dooming the multi-million-dollar satellite it carried. The ripple effect reached far beyond just the Falcon 9 mission. Other scheduled launches from various spaceports around the world had to be put on hold. Launch windows, carefully planned years in advance to avoid existing space junk, were now invalidated by the new dynamic debris environment. Many people are crazy about rapid launch capabilities, but this event showed just how fragile the system truly is. The delays alone cost millions of dollars and caused significant setbacks for scientific missions, commercial deployments, and even critical resupply efforts for the International Space Station. The notion of a predictable, orderly highway in space was shattered, replaced by an urgent, chaotic scramble to understand the new, perilous landscape. This single encounter, initiated by a space wanderer from deep beyond, exposed the vulnerability of our entire orbital infrastructure. What secrets did this chaos unveil about Space Command's own hidden vulnerabilities? The Command Center's paralysis. Inside the Combined Space Operations Center, or CSPOC, located at Vandenberg Space Force Base, California, the atmosphere was thick with tension. This is the nerve center for all United States military space operations, a place where highly trained guardians monitor everything from missile warnings to the health of crucial satellites. Following the Falcon 9 incident, the CSPOC, which typically functions with clockwork precision, found itself facing an unprecedented crisis. The flood of new debris data, combined with the frantic retasking of assets, pushed their systems to the brink. To put it mildly, the sheer volume of information was overwhelming, causing processing delays and momentary system outages. But not all things are what they seem. Amidst the chaos of the debris field, a far more insidious threat began to emerge. As Space Command scrambled to address the immediate orbital dangers, their sophisticated cyber defenses designed to protect against state-sponsored attacks began to register unusual activity. It was subtle at first: minor data packets, phantom signals, seemingly random fluctuations in network traffic. What many overlooked is that major disruptions in space operations create perfect cover for opportunistic adversaries. The most shocking fact is that while the world focused on the physical near collision, a stealthy, coordinated cyber attack began to unfurl, targeting Space Command's critical infrastructure. This wasn't a brute force assault. Instead, it was a highly sophisticated, multi-pronged digital infiltration, exploiting the momentary distractions and overburdened systems. The attackers aimed for the network's core, the very heart of Space Command's ability to coordinate and command its assets. Within hours, crucial communication links, vital for missile warning and satellite control, began to experience intermittent disruptions. Ground stations, which relay commands to satellites hundreds of thousands of miles above, reported unusual delays in signal transmission. You see, the interdependencies in modern space systems mean that a seemingly small cyber hiccup can have enormous cascading effects. A 1-second delay in receiving critical telemetry data could mean the difference between maintaining control of a satellite and losing it forever. The digital darkening wasn't a complete blackout, but a paralyzing slowdown. Decisions that normally took seconds now required minutes, as secure data streams stuttered and encrypted communications lagged. This effectively brought Space Command to a halt in terms of rapid response capabilities. Their ability to track new threats, reprioritize assets, or even confirm the health of their own satellites was severely compromised. It was like trying to navigate a complex labyrinth in a thick fog. Many people are crazy about advanced cybersecurity, but this event revealed a vulnerability not just in technology, but in the human element of command and control during extreme stress. The confusion generated by the Comet encounter provided the perfect smokescreen. The United States Space Force, the military branch dedicated to organizing, training, and equipping Guardians for space operations, was left reeling. Their mission to provide freedom of operation for the United States in, from, and to space was under direct assault. The ability to conduct space domain awareness, essential for detecting and identifying objects in orbit, was hampered. Their capacity for space superiority, which involves protecting against threats, was being tested by an unseen enemy. This wasn't just a technical failure, it was a profound strategic blow, paralyzing the very systems designed to defend national interests in the ultimate high ground. Who or what exploited the chaos to strike at the heart of our space defense? The aftermath's revelation. The paralysis at Space Command wasn't random, it was orchestrated. As the dust, both cosmic and digital, began to settle, investigators uncovered a chilling truth. The cyber attack, while expertly timed with the Falcon 9's near collision with 3I Atlas, was not a coincidence. You see, the initial assessment suggested a sophisticated nation-state adversary, but the forensic digital trail quickly led to something far more elusive. The thing nobody tells you is that some groups operate with a level of anonymity and technological prowess that rivals even the most powerful governments. This was an entity that meticulously watched, waited, and capitalized on a moment of universal vulnerability. The Unseen Architect was a shadowy organization known in intelligence circles as the Cosmic Harvesters. They aren't interested in political dominance or territorial gains on Earth. Instead, their motives are rooted in the pursuit of exotic materials and advanced technologies, often found in deep space. What many overlooked is that Comet 3I Atlas, as an interstellar object, represented a unique opportunity. Its composition, unlike anything found in our solar system, potentially held secrets about other star systems, raw elements, or even unknown energy sources. The most shocking fact is that the disruption at Space Command wasn't aimed at causing destruction, but at creating a window of opportunity, a momentary lapse in vigilance to perform their own clandestine operations. While Space Command wrestled with the cyber attack and the new debris field, the Cosmic Harvesters launched their own highly specialized stealth drones. These weren't powerful rockets, but small, agile craft designed for covert sampling. Their target? The very comet that caused all the chaos. One drone, barely the size of a sedan, was detected by a distant older military surveillance satellite, but its signal was too faint, too anomalous to be immediately recognized as a threat amidst the wider system failures. The Falcon Nine's near miss, the Space Command shutdown, and the shadowy players revealed a startling truth about our vulnerabilities beyond Earth. What if the real threats aren't asteroids, but the hidden forces that exploit them? Like and subscribe to unravel more cosmic mysteries.